Okay, we're looking at Geometry Unit 2 test review. Test will be tomorrow, and you'll see questions very much like the ones you find here on the unit review. So this first question, it asks us, or it tells us that the measure of RPZ is 95 degrees. Well, angle RPZ is this angle right here. It says that TU, RQ, and BW are all parallel. Find the measure of angle UZP. Well, UZP is this angle right here. Well, if these two lines are parallel, then these two angles, and they're cut by this transversal, these two angles are congruent because they are alternate interior angles. Therefore, the measure of UZP is 95 degrees as well. Okay, all the angles congruent to these, well, of course, vertical angles, alternate interior, and vertical, since they're all parallel, we can find all these 6 angles to be congruent. Okay, number 2. Complete the statement. If a transversal intersects two parallel lines, then corresponding angles, these are just facts that we have to remember, corresponding angles are congruent. Same side interior angles are supplementary. And alternate interior angles are congruent. Alternate exterior angles are congruent. Really, the only ones that are different are these same side. Another word for that, remember, is consecutive. Okay. Number 3, an equation of a line perpendicular to y equals to this line right here. Which of the following lines can be perpendicular? Well, the way we know that is by looking at the slope, since this is in slope-intercept. If the slope is 2 and we need a line perpendicular, then remember it's going to be the opposite sign, so this is positive, so our slope is going to be negative. And the reciprocal of 2, which a whole number is 2 over 1, so the reciprocal would be 1 over 2. Which of these has a slope of negative 1/2? That one does not. That one's 1/2, but it's not negative. 2, that one's not, and we have negative 1/2 here. And that's really all we're looking at on number 3. Number 4, they give us the angle of the measure of angle 6, which this is angle 6 right here. And I'm sorry, angle 1 they give us the angle of, which is, I'll do it in green here. Angle 1 is right here, and it is 6x. Angle 3 is 108 degrees. That angle is right here. Find the value of x, right here, for P to be parallel to Q. We have these two lines, P and Q. Well, in order for these two lines to be parallel, these two angles must be congruent. And if they're congruent, we can set 108 equal to 6x. And that's my equation. Solve for x. X equals 18. 108 divided by 6 is 18. So we've solved for x. And now, the one they gave us, angle 3, that was 108 degrees. We already said that angle 1 was congruent to that, so that's also 108 degrees. Notice that angle 3 and angle 6 are vertical angles, so they're congruent, so angle 6 is 108 degrees. Let's look at these two angles right here, angle 1 and angle 2. They form a linear pair. If angle 1 is 108 degrees, then what must angle 2 be, because they are supplementary? We subtract 108 and we end up with 72 degrees. That means angle 2 is 72 degrees. Well, it also is, if these lines are parallel, it's corresponding to angle 4. That makes angle 4 72 degrees as well. Angle 5 is vertical to angle 4, so it's 72 degrees. And that follows with the rule that we really only have two different angle measures when dealing with parallel lines in a transversal. Okay, let's move on to number 5. Alright, which condition will guarantee that line L is parallel to line M? Let's look at A first. It says 3 is congruent to 5. Well, 3 and 5 are alternate interior angles. If alternate interior angles are congruent, then the lines are parallel. That right there is a true statement, A. Now, if we're looking at B, 1 and 3, are they congruent? 1 and 3, they are, but those are vertical angles, and they have nothing to do with proving lines to be parallel. 1 and 6, well, they actually are not congruent, and they have no relationship to prove lines parallel. 6 and 5, those two are supplementary. They form a linear pair. And again, nothing to do with proving lines vertical. So my answer there is definitely A. Okay, number 6. Line N intersects PQR and S, forming the indicated angles. Which of the two lines are parallel? Well, look at R and S. Those two angles are corresponding angles. They are not congruent. If those two lines were parallel, R and S, they would be congruent. Let's look at P and Q. If that angle is 130, then this angle also is 130. And if lines were parallel, then 130 and 40 should equal 180, because they should be supplementary. But we get 170, which shows that those two are not parallel either. P and R, we're looking at these two lines. If P and R were parallel, that 130 degrees would be corresponding to this angle, which forms a linear pair with this angle. So 130 plus 50 should equal 180 if those are parallel. And it does, which means that P and R are parallel. Looking at Q and R, these are alternate exterior angles. Let me get a different ink so we could see it. This angle and this angle are alternate exterior angles, and they should be congruent. These are not, which is why Q and R are not parallel. Alright, let's look at number 7. Okay, here we have a construction engineer needs to make sure a ceiling beam is parallel. So he's just wanting to make sure that this beam is parallel to this beam. Using the drawing as a guide, which pair of measurements is sufficient to know that the beams... So basically we have to check which angles need to be congruent in order for those to be parallel. So let's look at Y and Z. Y and Z, here we have angle Y, here we have angle Z. Do those have to be... What relationship do those have? That we're really dealing with two different transversals, this one and this one. So we really have no way of proving lines parallel if we were to know that those two were equal. Y and W, there's Y and there's W. Again, we're not even talking about this line, so these two angles will do nothing to prove that the ceiling beam and the floor beam are parallel. X and Y, we're talking about this angle, and those are formed by this transversal and these two lines. They're alternate interior angles, so if they're congruent, then lines are parallel. Well, we're saying they're congruent, which means that is what we need to know in order to prove that the lines are parallel. And then X and Z, again, that won't prove it because I can show you that. X and Z, these two angles have nothing to do with this floor beam, so they can't be possibly proving that the ceiling beam and floor beam are parallel. Okay, we have another drawing here, and it says that AB is parallel to CD, or A and B are parallel, C and D are parallel. Which angle is not necessarily congruent to angle 1? One thing you can do right here is to just go through and find all the angles parallel to angle 1, which would be angle 6 because it's vertical. If we wanted to find out what an alternate interior angle to 6 was, we would say that 9 is. We would also say that 3 is. 3 is also corresponding to angle 1. 9 is corresponding to angle 1. Once we find that, we can find vertical angles. And then we can continue to find corresponding angles there, which would give us 16. And then vertical angles of 11. So which of those is not congruent to angle 1? Well, is 16 congruent to angle 1? Yes, we saw our mark, so that's not my answer, because remember, it's not congruent. Angle 3 is congruent to 1, that's not my answer. Angle 9 is congruent to angle 1. Angle 12, notice we did not say that angle 12 was congruent to 1. That is my answer. Okay, number 9. In the figure, we have P parallel to Q, so I'm going to just go ahead and redraw some of this. Q is parallel to P. Find the measure of angle 1. The measure of angle 1 we're talking about is right here. Draw a line through S that is parallel to Q. Now this one is one of those tricky ones. We're going to draw this auxiliary line, which is going to be parallel. So this is what we do. When we do this, we see that this angle right here is 125. By doing that, we find this angle is corresponding, so it also is 125. Well, that angle is supplementary to this angle, so 125 plus whatever that angle is should be equal to 180. Subtract 125, and we find that x equals 55, which means this angle right here is 55 degrees. The entire angle, let's see if I can read that, it's 119, which means if I take 119 and subtract 55, I should get the rest of that angle, which is this right here. Now, you'll notice that it is corresponding to angle 1, so this 64, should also be this angle, because they are corresponding angles, which means the measure of angle 1 is D. Kind of a tricky one. That auxiliary line really throws you off, but when you draw that line on there, then you see how many of those angles you can find and find which one is congruent to angle 1. Alright, let's look at number 10. Alright, if you see this problem, I'm going to just go ahead and make a recommendation of what you should do. I would just go ahead and extend the line, just so we have a little bit more of a reference. It looks a little confusing when we don't see where it continues. A and B is parallel, or line AB is parallel to CD if So we're talking about this line and this line. What has to be true in order for those lines to be parallel? 1 is congruent to 2. Well, if we see that, we have these two angles right here. They really have nothing to do with line CD, so that's not going to be our answer. And again, 3 and 4 have nothing to do with line AB. That's not going to be our answer. And then we have the measure of angle 1 plus the measure of angle 2 should be equal to the measure of 3 plus the measure of angle 4. That is actually our answer, and I'll explain why. Our parallel lines are cut, or our lines are cut by this transversal. This angle is alternate exterior angle to this one. That means the measure of angle 1 plus the measure of angle 2 should be equal to the measure of angle 3 plus the measure of angle 4. As far as D is concerned, 1 plus 2, it may look like it's 90 degrees, but even if it was, that does not prove that the two lines are congruent. So our answer there is C. Okay, this is from Unit 1, this question right here. Determine the slope of the line that contains the given points. If you remember how to find the slope, we take our y-coordinate, which let's start with 5. We subtract our other y-coordinate, which was 2, 5, and 2. We divide that by our x-coordinate, 8 minus 2. Notice I started with 5 as my y, and I started with 8. It doesn't matter which one we pick, but whichever y we start with, we have to start with that x as well. So 5 minus 2 is 3. 8 minus 2 is 6. So my answer is 1/2. That is my slope. Okay, write an equation in slope-intercept form. They've given you everything. This is your slope. This is your y-intercept. So it always starts with y equals my slope, -3/7x, and my y-intercept, which here is -10. And that's my answer. Write an equation in point slope. So here's my point, here's my slope. Let's put that in point slope. We always start with y minus my y-coordinate, which in this case is 3, and we set that equal to my slope, which is 5, parentheses x minus my x-coordinate, which was 4. And that's point slope form. Write the equation in slope-intercept form of the line that is perpendicular and has the same y-intercept. Well, remember, we just did one like this a few problems ago. If this is my slope, or if this is the slope that's perpendicular, then we take the opposite reciprocal. So my new slope is going to be, that's positive, so my new slope is negative, and I flip it 3/5. Now my y-intercept is the same, so that's going to be -7. So I write the new equation in slope-intercept form, which is simply y equals my slope, -3/5x, and my y-intercept, which is -7. Alright, let's check out number 15. Okay, find the value of x. Well, these we have to know our rules and be able to identify the relationships between angles. We have parallel lines. They're cut by this transversal. So these are corresponding angles, which, if lines are parallel, corresponding angles are congruent. Subtract 2x, get my x's on one side, get my numbers on the other side, isolate my variables. We end up with x equals 16. Okay, again, I have parallel lines with a transversal. Angle 120 and angle x, they really have no relationship. However, this line is vertical, which makes it 120 degrees as well. Well, and that makes x same side interior, which same side interior angles are consecutive, have a sum of 180. They're supplementary. So 120 plus x equals 180 degrees. Subtract 120 from both sides, and we find that x equals 60. We have parallel lines, which are cut by a transversal. We have this angle and this angle. Those are alternate interior, and alternate interior angles are congruent. So 2x plus 2 is equal to 5x minus 10. Isolate my variable. Equals 3x. So we'll divide by 3, and x is equal to 4. Alright, let's look at the next problem. Find the specified quantity, if not possible, state y. Show your work. Find the value of x and y. Okay. So here we have parallel lines cut by transversal. These are corresponding angles, so they're congruent. So 7x minus 28 is equal to 5x plus 12. And we'll solve for x. Find that x equals 20. Well, if x equals 20, I can find the measure of this angle. So 5 times 20 plus 12. Well, that's 100. Plus 12 is 112. So we have 112 degrees. I'll write it over here. And it forms a linear pair with angle y. So they are supplementary. They add up to 180. So that would be my equation to solve for y. Subtract 112, and we find that y is equal to 68. Alright, let's look at the next one. Here we have parallel lines cut by a transversal. These two angles that are given, they really have no relationship, but angle 54 is corresponding to this angle, which makes this angle also 54. These two angles make a linear pair, so when I add them up, they equal 180 degrees. So 54 plus, can't read that angle, is that 6x? Yeah. Plus 6x plus 12 equals 180 degrees. So that would be 66 plus 6x equals 180. Let's subtract 66 from both sides. We're isolating the variable. 6x equals 494. No. 180 minus 66 would equal 114. Divide both sides by 6. And x equals 19. There's no y. There is no y in this one, so we're good right there. Okay, C is tricky because if you'll notice, we have parallel lines cut by a transversal. So this is congruent to this angle. This is corresponding to this angle. Now be very careful because this angle, or this line, does not say that it's parallel to this line. So if it's not parallel, we cannot make any assumptions as to lines of congruency or angles being congruent, which is that if not possible, state why. What we would say is not possible, and we only have only one pair of parallel lines. We would need two pairs in order to make that conclusion that these angles have a relationship to this angle. Alright, and the last one on this page, find the value of x. Well, we have parallel lines, we have a transversal, which means these two angles are same side interior or consecutive, which means they're supplementary. So 6x plus 12 plus 4x plus 18 equals 180. We'll combine like terms. That's 10x plus 30 equals 180. Subtract 30. Divide by 10. And we get x equals 15. That would be our solution. Alright, let's look at the next problem. Number 17. Use the diagram to the below for the next 5 questions. Okay, so let's look at question A. Angle 1 and 7 are, notice that these are two parallel lines cut by a transversal. That means 1 and 7 are alternate interior. They're both interior in between the parallel lines, and they're on opposite sides of the transversal. So they are alternate interior angles. 2 and 3 are, well, that should be the one that we're getting pretty good at. Those are vertical angles. When only two lines are involved, you're going to either have vertical angles or linear pair or supplementary. 6 and 1 are, where's 6 and 1? Here's 6, here's 1. Those two angles are same side interior. They're not corresponding, they're not vertical, they're not perpendicular. They are same side interior or consecutive, which, if you know anything about those, they are supplementary. And let's look at the next one, 5 and 7. Let's mark those up. 5 and 7. Again, those are just vertical angles. It's an easy one. And 7 and 2. Let's find 7 and 2. Angle 7 and angle 2. Well, they have no relationships. However, 7 is corresponding to angle 4, which is a linear pair. That means that these two angles are supplementary. So if 2 and 4 are supplementary, 4 is congruent to 7, 2 and 7 are also supplementary. Okay, let's look at the next problem. Okay, a pathway divides a rectangular garden into two parts as shown. Find the measure of A. So we're going to go ahead and say that we have two parallel lines cut by a transversal, with this angle being angle A and this angle being 78 degrees. Not congruent. Find the measure of angle A. Well, these are same side interior, which means they are supplementary. So we add them to each other to equal 180. Subtract 78 degrees, and we find that A is equal to 102 degrees. Okay, 19. Solve for y and graph the line on the grid provided. State the slope and the y-intercept. So we have to first change this from standard form to slope-intercept form. How do we do that? Just like they said, we were going to solve for y. So we're going to subtract 2x. So we've got 3y equals 6 minus, or actually, let's go ahead and put minus 2x here, since that's how slope-intercept looks, plus 6. We're going to divide by 3. And our slope-intercept form ends up looking like this. Y equals negative 2/3 x plus 6 over 3, which simplifies to 2. The slope, I guess the number in front of the x, which is negative 2/3. The y-intercept is the number after the x, which is 2. And then we're going to graph it so it crosses the y-axis at 2, and it has a negative slope of 2/3, so it's going downhill from left to right. The rise is 2, 1, 2, the run is 3. 1, 2, the run is 3. So it's going to look something like that. Okay? Alright, moving on to number 20. Write an equation in the slope-intercept form that models the line between station A and station B. And they give us that information above. 2 hydroacoustic stations to detect underwater explosions. A is located and B is located, so basically we have to find the slope of these two lines. Remember how we do that? We take y over x. So I'm just going to pick negative 280 minus negative 320 over 30 minus 70. 28 minus, we would end up having plus, minus a negative becomes plus. That would be 292 over 30 minus 70, which is negative 40. Simplify that. Make sure I did this right. Oh, I wonder, it should be 280. Didn't think that I had a weird number like that. So negative 280 plus 320 would leave us with 30, which would simplify to negative 3/4. So that is my slope. I'm writing point slope. I'm going to use this point. So y minus my y coordinate, which is negative, so minus a negative becomes plus 280, equals my slope, negative 3/4, times x minus my x coordinate, which is 30. Okay, distribution, what that means is I'm going to distribute my 3/4 to each of those terms. So I end up with negative 3/4 x, and let me distribute negative 3/4 times negative 30 would be positive 90 over 4, which would simplify to 22 1/2. We'll say 22.5, which again, a negative times a negative is positive, so plus 22.5. Slope-intercept form, how do we do that? We then subtract 280 from both sides. And we end up with y equals negative 3/4 x minus 257.5, or 1/2 if you left it as a fraction. Okay, so that is what the line looks like in slope-intercept form. Okay, I just paused this and took a look at what I was doing because it didn't seem right, and you probably caught my mistake. What I did was I ended up with 30 here as my numerator, but I guess I don't know how to subtract 280 plus 300, positive negative 280 plus 320. I should have got a 40 right here, which would have given me a slope of -1, not -3/4. So let's change this up. Basically ignore everything below this line. If I had gotten that answer, we would be good, but I'm going to go ahead and erase this if it will let me. Let's see, I'm still working here. 1 second. Alright, I'm just going to slide down a little bit, and we're going to check this out again. So we got a slope. When we did this, we should have got -280 plus 320 should have given us 40 as the numerator, over 30 minus 70, which would have given us -40. So my slope is actually -1. Okay, when I plug that in, this should look the same, except this should be a 1 because my slope is different. When I distribute that, this is a mess, isn't it? When I distribute that, I get y plus 280, -1 times x should give us -x. -1 times -30 would give us +30. So that is my distribution. Now I'm going to isolate it, put it in a slope-intercept, so minus 280. And we should get y equals -x minus 250. I'm sorry about that. But that is how it should look. The process was the same. I got the wrong slope, so I basically did the wrong thing. So I guess you could take that as an example of why you got to be careful when doing these computations, because one silly mistake makes you miss the entire problem. So that is it in slope-intercept. I hope this study review helps you do well on the test tomorrow. That's it.